Hello everyone, I am Athara Zamdade, a visiting summer researcher at Sys-MoDEL. Today I will walk you through the step-by-step guide to learn the MapleSim CAD Toolbox. So we will start with importing a CAD file to MapleSim from a CAD software. So you can select Import CAD. MapleSim will offer you numerous options to import CAD files. The CAD types range from AutoCAD 3D file, Autodesk Inventor Assembly, CATIA files, Creo, SolidWorks, Fusion 360, as well as a few generalized file types like STEP and IGS file types. So you can just select a file and open it. So MapleSim will open the file into a new window of CAD Toolbox. Once you have opened the CAD file successfully in the CAD Toolbox, you can see a drop-down menu on your left side, which includes the components or bodies grouped together in numerous groups. So when you import a CAD file to the CAD Toolbox, it retains the geometries, rigid body frames, shapes, and positions of the components and bodies from the CAD file, but it won't import or retain the joints or set of joints between two components or two bodies. So to create a joint or mention a joint between two bodies, we have to start creating coordinates or point of interaction between two bodies. So to start with mentioning the coordinates, select place coordinate, go to a body on which you have to mention the coordinate, select the location of coordinate. Let's say there is a revolute joint between the body or link 3 and link 2. So you go to the link 2, hover the mouse over the hole and place the coordinate over there. Now there will be one more coordinate between the link 2, that is link 2, and link 1, and link 1. So similar process is followed over here. Go to the hole, hover your mouse over there and left click. We will also name the coordinates. So let's say the coordinate 1, which is on link 2, we'll name it as R1, where R stands for revolute joint. Similarly, the coordinate 2, which is on link 1, we'll name it as R2. So now to create a joint between link 2 and link 1, that is a revolute joint at coordinate 2, we have to copy paste the coordinate 2 on coordinate 2, that is on link 1, to the link 2, so that you can create a joint between link 2 and link 1. So for that, you select R2, copy it, and then go to link 2 and select paste. So you can see it will automatically create a reference coordinate R2, which is copied from the main coordinate or parent coordinate R2. We'll do similar for R1, which we have to copy from link 2 to link 3. Okay, so we'll follow similar process for the remaining coordinates. We will start with creating a coordinate between link 3 and link 4. So we'll isolate the link 3 and put a coordinate over here. Cool. So now it's time to show all. You can go to link 3, coordinate 7, let's name it as R3, and we have to copy paste R3 on link, so we have to copy paste R3 on link 4. Let's delete the coordinate that I have created by mistake. So to delete the coordinate, right click on the coordinate and select delete. Done. So we have created a reference coordinate R3 on link 4. Now we also have to create a coordinate to mention or to make a joint between R4 and the ground. The joint will be a slider joint. So for that, we have to isolate the link 4, select coordinate and place it on the top surface. Let's name this, let's select show all. Let's name this coordinate as S1. Now we'll copy this coordinate, copy and paste on the link 1. We also have to create a coordinate for ground on the link 1. For that, you can select any corner of the link 1 and place a coordinate over there. Name it as ground. One thing that you have to ensure that the location of the coordinate should be 0, 0, 0. Even the degrees should be 0, 0, 0 for the ground coordinate. Now, as we have created all the necessary coordinates, the revolutes, the slider and the ground coordinate, we'll select accept and return. Now the CAD Toolbox will create a hierarchy of components in the MapleSim. So you'll get a pop-up saying that finished importing the CAD model, and all created components have been placed into the hierarchy under hierarchy/ladder crank V7. So you can go to the local components, select hierarchy, and under the drop down menu you can see the components that we created right now. So you can drag and drop them on the MapleSim interface. Okay. Yep. So we have all the components together right now. You can select show port labels so that it will be easy for us to create joints between two or more than two bodies. So this, now let's pull out the joints. Go to the multibody library. Under joints and motion, you can drag and drop revolute joint as well as the prismatic joint for the slider. We also have to drag and drop the fixed frame for the ground. So we'll start creating the joints between different bodies. Now the importance of naming the joints properly will come into the picture. So let's start with this first. Let's keep it here. R2. Let's flip it. So there is a common joint R2 between both the bodies. Bring a revolute over here. Join it. Now we have R1 between the blue and the red link. You can just copy paste this joint. Sorry. Okay. Now again R3. We'll just rearrange it a bit. Now comes the prismatic joint. Let's flip it. So as we have joined all the components together with the desired joints, let's try to simulate the model and see how it goes. Okay, so the simulation has been completed. Let's try to run the model. Okay, so as we can see, the model is not working. The reason behind is that we have not grouped the ground linkages properly. So the linkage that the mouse cursor is hovering at, the link 1A and the link 1B, the slider link to the ground, has not been grouped together and then grounded. So what we can do right now is we will group both the links together and then we'll attach a ground to them. So let's do that. We'll go to the attached files. Then under CAD models, we'll open the slider Kang v7.step. It will open the CAD Toolbox wherein we were mentioning the coordinates. So this is the link 1B1 and this is the link 1A1. So we have to group them together and then attach the joint. So for that, you can drag this link and then just drop it on the link 1A1. So both of them are now grouped together. And now we will select accept and return. The software will automatically modify the components and will show the same pop-up window. You select OK. So as you can see, under the hierarchy, it has grouped the link 1A1 and B1 together. So we'll delete the previous model. Okay, now let's try to simulate the model. Before that, let's attach a actuator to our revolute joint so that it will rotate on its own. For that, we can go to the library components, only mechanical, rotational, common, or select the constant speed. Okay, so now let's try to simulate the model again. Okay, so now the model is working as desired. Now we will attach a probe to the slider to examine its motion during the entire cycle. For that, let's get back to the interface. So we will select the prismatic joint and attach a probe to the joint, and we have to examine the S of the probe. So let's rename it as slider motion. So now we are good to go. We'll rerun the simulation. Let's play it once. Okay. Now we'll click on the simulation results. We'll go to the probe plots and select the slider crank. So you can see how the slider behaves during the entire cycle. It follows a cyclic motion similar to a sine curve. Now I will run the simulation again. So that was all about getting to know the CAD Toolbox and learning it in step-by-step manner. I hope you found the video insightful. Soon I will come back with a new video showing how to develop a double wishbone suspension. So please stay tuned. Thank you.